awak yang tu lah. Jangan lupa subscribe channel kita, tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. Welcome back to my channel. So in this video, we will continue with the second part of the extra example for chapter 3. So let's get started. Okay guys, so let's start with example number 1. So now look at here. We have one battery or EMF with 10 volt of voltage, and it's connected with R1, okay, which is 4 ohm and 2 ohm resistors. Okay, we have 2 resistors here. Okay, so if the reading shown by the ammeter is 2 ampere, so let's write the reading of the ammeter is, here is I is equal to 2 ampere. Okay, find the value of internal resistance R for the battery. Okay, so we have the internal resistance in the battery. Okay, so I want to find what is the value of the internal resistance here. Okay, so we put small r here, and this is stand for the internal resistance. Okay, so as we know, so this is our battery, and inside the battery we do have the internal resistance. Okay, so now look at this circuit. Okay, so let's draw the flow of current. Okay, so I want to label the flow of current here as I. Okay, so what happened when the current I reach the junction? Okay, so I will split into two parts, which is I1 and I2. Okay, where I1 will flow through R1, okay, and I2 will flow through R2. So actually, the ammeter will read the reading of the current of I1. Okay, so let's write here, the blue color here is I1. Okay, so what happened when I1 and I2, okay, so here we have I1 and here we have I2, and when they meet together, okay, at this junction, they will combine, and here is I, okay, and I will flow through the internal resistance. Okay, so from the information given, okay, we can find what is the voltage across R1, which is V1, and what is the voltage across R2, which is V2. Okay, so now I want to write V1 is equal to I1 R1, where I1 is equal to 2 ampere and R1 is 4 ohm, and V1 is equal to 8 volt. Okay, now, so look at this circuit. So from this circuit, we can see that the position of R1 and R2 are parallel. Okay, so since R1 and R2 are parallel, therefore, we can write the voltage across V1 is equal to the voltage across V2, and it's equal to 8 volt. Okay, so from this information, I've already known that the voltage across V2 is equal to 8 volt. Alright, so now I want to find what is I2. Okay, so I want to know what is I2. Kenapa saya nak tahu I2? So now I want to simplify this circuit because I want to show you why I want to find I2. Okay, so if we simplify this circuit, so let's say we want to combine R1 and R2, okay, and it will become R total, and here we have internal, this is EMF, okay, so we're going to have current I. Okay, look at here. So now we're going to have I. Since I is equal to I1 plus I2. So here, we already know what is the value of I1, but I don't know what is the value of I2. So that's why I need to find what is the value of I2. Okay, So from here, from V2, we can find I2. Okay, where I2 is equal to V2 over R2, where V2 is 8 volt over R2 is 2 ohm and I2 is 4 ampere. Okay, so now we can write here I2 is 4 ampere. Okay, guys, you can see here when I1 is 2 ampere and I2 is 4 ampere, okay, bila mereka bertemu dekat junction ni, they combine, okay, I1 plus I2 and they become I. Okay, so I is equal to I1 plus I2. So let's write, okay, I is equal to I1 plus I2. Okay, I is equal to I1 plus I2, where it's equal to 2 plus 4 is equal to 6 ampere. Okay, so now before we proceed to find what is the internal resistance of the battery, so let's calculate first what is the total resistance of the circuit. Okay, the total external resistance, okay, RT. Okay, so let's put a color here, okay, the blue color here. Okay, let's highlight. So I want to calculate what is R total here. Sorry. Okay. Okay, where R total is for the parallel circuit. Okay, so for the R total for parallel combination, so 1 over R total is equal to is equal to 1 over R1, where R1 is 4 ohm, plus R2 is 1 over 2 is equal to, okay, so R total will equal to, so R total is equal to 1.33 ohm. Okay, so now let's proceed to find what is the value of internal resistance. So based on the general equation of the EMF, since we already know that EMF is equal to terminal voltage plus voltage across internal resistance, or we can write as EMF is equal to IR total plus IR. Okay, so from here we can calculate what is the internal resistance. So I want to factorize this one. Okay, RT plus R. So let's substitute. EMF is 10. So here we have 10. And the objective now, we want to calculate what is the internal resistance here. Okay, so let's substitute the value of I, where I is equal to 6 ampere. And R total is 1.33 plus small r. Therefore, small r is equal to 0.33 ohm. Okay, so finish example number 1. So let's proceed to example number 2. Okay, example number 2. So here we have a figure shows a complete direct current circuit. Okay, and the question asks us to find the readings for ammeter. Okay, so look at here, we have ammeter here. So we want to find what is the reading of the ammeter. So means that we want to find what is the value of current that flow in the circuit. Okay, and we want to find what is the reading for the voltmeter V1 here, and also voltmeter of V2 here. Okay guys, for your informations, V1 here, okay, or voltmeter 1 will measure the terminal voltage. Okay, so let's write. Here we'll measure the terminal voltage of the circuit. Okay, where V2 here will measure the voltage across external resistor R. Okay, this one is voltage across external resistor R, or VR. Okay, so you want to calculate what is the reading of A. Okay, that's mean we want to calculate what is the amount of current that flow in the circuit I. Okay, so let's start. Question number 1. Okay, we want to calculate what is the value of current I. So based on the equation, so since we have the internal resistance in the battery, so we have EMF is equal to IR plus R. Okay, so this is the general equation. Okay, or you can write the general equation EMF is equal to terminal voltage plus voltage across internal resistance. Okay, saya dah tunjuk berapa kali tadi kan. So EMF is equal to IR total plus IR, where R total here is the external resistance. So this refer to the external resistance. Okay, and here is internal resistance. Okay, so we're going to have this as our reference. Okay, so now let's proceed. So now let's proceed. So EMF is given as 12 volt. All right, and we want to find external resistance. We just have one resistor here, which is 4 plus internal is 2. Okay, so 12 plus 6, therefore I is equal to 2 ampere. Okay, so the reading of ammeter will show us the reading of current, therefore and the reading of ammeter is equal to 2 ampere. Okay, so next, question number 2. Okay, so we want to calculate what is the reading of voltmeter 1. So the reading of voltmeter 1, as we know here, the reading of voltmeter 1 will read the reading of the terminal voltage of the circuit. Okay, the reading of voltmeter 1, we read the reading of the terminal voltage of the circuit, VT. Okay, so we want to calculate what is terminal voltage of the circuit. Therefore, let's write, okay, EMF is equal to terminal voltage plus voltage across internal resistance. Okay, so yeah, so let's write EMF, okay, VT is equal to EMF minus voltage across internal resistance. Okay, so EMF minus VR is I times internal resistance. Okay, so now EMF is equal to 12 minus I is 2 and the internal resistance is given as 2. Okay, therefore we're going to have the terminal voltage is 12 minus 4 and it's equal to 8 volt. Okay, so since the voltmeter 1, we read the reading of the terminal voltage, therefore the reading of voltmeter 1 is equal to 8 volt. Okay, so finish question number 2. So now question number 3. Okay, so question number 3. Okay, so we want to calculate what is the reading of voltmeter 2. Okay, so the reading of voltmeter 2, okay, look at here. Okay, voltmeter 2, we read the voltage across external R. So here we just have one external R. Okay, so for your information, okay, if we have, okay, wait, I change color. Okay, for your information, okay, if there is only one external resistor R in the circuit, okay, therefore V terminal will equal to voltage across R. Okay, remember? Okay, so in this case, okay, look at this circuit. Okay, we just have one external resistor. So automatically, the voltage across the external resistor will equal to the voltage of the terminal voltage. Okay, so how if we have more than one resistor, more than one external resistor? Okay, so let's look at this circuit. Let's say we still have same battery, okay, with the same internal, okay, but we have R and another R here. Okay, so this is the reading of V1. Okay, and let's say this is V2. Okay, so R and R. So if we have more than one external resistor, okay, so let's write, okay, if more than one external resistor R, okay, so V terminal is not equal to VR. Okay, in this case V2 lah. So in this case V1 is not equal to V2. Okay, so kita kena kira asing. Boleh? Okay, so in order to answer this question, we want to calculate what is the voltage across VR. We can straightly use this equation. VR is the voltage across external resistance R. Okay, we put the voltmeter, okay, V2 here. Okay, so we put the voltmeter here because we want to measure what is the voltage across R. Okay, so we want to calculate what is VR. Okay, so therefore VR is equal to IR. So you can straightly calculate. So since we already know that I is equal to 2 and R is equal to 4, so VR is equal to 8 volt. Okay, you can see here, okay, VR is equal to V terminal, VT. Okay, this happen only if there is one external resistor in the circuit. If more than one, then the terminal voltage is not equal to the voltage across the external resistor. Okay, so we need to calculate separately. What is the voltage across R here and what is the voltage across this one? Okay, the second one. Okay, so we need to calculate, okay, what is the voltage across each resistor in the circuit. Okay? Okay, so finish example number 2. Let's proceed to example number 3. Okay, example number 3. So this is about potentiometer, and this potentiometer consists of wire XY. Okay, and the length of wire XY is given 1.5 meter, and the resistance of this wire from X to Y is given 5 ohm. Okay, so given that a cell of EMF 2 volt here has the internal resistance of 1 ohm. Okay, so when the unknown cell is connected here to the potentiometer, the balance length XP, okay, is found at 72.6 centimeter. Okay, so let's write. Okay, so here is 72.6 centimeter. Okay, from X to P. Okay, so before that, let's write the information given that length XP is equal to 1.5 meter, where the resistance of XP is equal to 5 ohm. Okay, so when the potentiometer is said to be balanced, means that the reading of the galvanometer here is equal to 0. Okay, we can write here that IG is equal to 0, means no current flow through the galvanometer. Okay, initially we have a current, okay, from the battery, okay, from the EMF of 2.0 volt. Okay, and what happened when we slide the jockey and we reach a point P? So when the position of the jockey at point P, okay, so the reading of galvanometer is equal to 0. So at this moment, the potentiometer is said to be balanced. Means that current cannot flow through this galvanometer. So current from here will flow downward and move to the right and reach point P, and current cannot flow through this galvanometer. Why? Okay, so when the potentiometer is balanced, so the voltage of Vxp here, so Vxp is equal to the voltage of EMF. So when the galvanometer shows 0 reading, means that voltage across Vxp is equal to voltage of the EMF. And always remember, current will only flow from higher potential difference to lower potential difference. So this is the reason why current from the EMF here cannot flow through the galvanometer when the potentiometer is balanced, because the voltage at this area is equal to the voltage at this area. So current from this area cannot flow into this area. Okay, so no current flow through the galvanometer. Okay, so the very important point is the voltage Xp is equal to EMF. Alright, okay, so now let's look at to the ratio here. So the second point, you must know that if the question gives you the length of the total wire, which is the length from X to P is 1.5 meter, okay, and given that the resistance of the whole wire from X to P is 5 ohm, therefore we can calculate what is the resistance from X to P. Oh, sorry, so this should be from X to Y. Okay, this should be from X to Y. Okay, so now this LXP, so given that LXP, so I want to change to meter, so it should be 0.726 meter, and I want to know what is the resistance from X to P. Okay, so we don't know what is the amount of resistance from point X to point P. Okay, so let's do the ratio. So this is very important. Okay, I always remind you to do the ratio method. Okay, so if the length of wire is 1.5 meter with a resistance of 5 ohm, so if the wire now is 72.6 centimeter, for example, so then what is the resistance? Okay, so we can do the ratio, right? Okay, so let's write, okay, LXY over LXP equal to RXY over RXP. Therefore, we want to find RXP, right? RXP is equal to LXP over LXY times RXY. Okay, so now let's proceed to the next part. We want to calculate what is the EMF of the unknown cell. Okay, so let's try to change the color first. So now, based on this information, so Vxp is equal to IRxp. Okay, so remember, Vxp is equal to IRxp. So now, I want to calculate what is the amount of current that flow in this circuit. What is the amount of current that flow in this circuit? So let's calculate I first. Okay, so how to calculate I? Okay, so EMF equal to I, okay, times external R plus internal R. Okay, so in this case, we have two external resistance. Okay, the first resistance is RSY. Okay, this is our first external resistance, this wire. because this wire comes with resistance Rxy. Okay, and the second external resistance is 1.5 resistance. Okay, so this is our second resistor that come with 1.5 resistance, right? Plus another internal resistance. Okay, so let's calculate the current. So current I, so now I is equal to EMF over external resistance is Rxy plus resistor R and plus internal resistor. Okay, so let's substitute the value of the EMF, which is 2 volt over Rxy is 5 ohm plus 1.5 plus internal resistance is 1. Okay, so therefore, so current will equal to 0.267 ampere. Okay, so current is equal to 0.267 ampere. Alright. Okay, so now I will proceed to the second part. I want to find Rxp, right? So remember, Rxp, we can get the value of Rxp from the ratio method. Okay, remember from the ratio method here? Okay, so Rxp now is equal to Lxp, which is 0.726 over Lxy, which is the length of the whole wire, 1.5 meter, times the resistance of the wire from X to Y is 5 ohm. Okay, and the resistance from X to P is equal to 2.42 ohm. Okay, so finally, we can calculate what is the value of Vxp, which is equal to IRxp, and 0.267 times 2.42, and it's equal to 0.645 volt. Okay, so since we know that, we can write, so since Vxp is equal to the unknown EMF, therefore, okay, so let's write here, therefore EMF is equal to 0.645 volt. Okay, so this is the answer. Finish example number 3. So let's proceed to example number 4. Okay, so example number 4. So we have another potentiometer. Okay, so we use this potentiometer to determine the EMF of a thermocouple. So given that the sliding wire has the resistance of 4 ohm and the total length of the sliding wire is 100 centimeter. Okay, so the EMF of the accumulator is given as 2.0 volt. So at a balance point, the balance length for the thermocouple of EMF 6 millivolt is 60 centimeter. Okay, so means that when the reading of the galvanometer is equal to 0, okay, the position of the jockey is at point Q. Okay, and the balance length is recorded as 60 centimeter, and calculate the value of R prime. So we want to determine what is the value of the R prime here. Okay, so we already know that the EMF of the thermocouple is 6 millivolt here. So here is 6 millivolt. So when there is no current that flow through the galvanometer and the potentiometer is said to be balanced, means that the potential difference at PQ, so VPQ, is equal to the potential difference of the thermocouple. Okay, so let's write the condition, okay, where when IG, okay, not your Instagram, okay, so when IG current flow through the galvanometer is equal to 0, therefore VPQ is equal to 6 millivolt. Okay, so this is the condition. Okay, so since VPQ is equal to 6 millivolt, so as we know, when the current flow from the positive terminal of the EMF and its flow, okay, in the upper circuit here, so the current cannot flow through the galvanometer. Okay, since VPQ is equal to the EMF of the thermocouple, so current cannot flow downward. Okay, because as we know that current only flow from higher potential difference to lower potential difference. So kalau dia dari kawasan yang sama, daripada sini nak pergi sini, so tak boleh. Okay, so now let's continue. So we can write that as we want to find R prime, therefore we can write VPQ is equal to IRPQ. Okay, so V is equal to IR. So from Ohm's law, so VPQ, we already know that VPQ is equal to 6 millivolt. And then we can calculate I and RPQ by using the ratio method. Okay, and one more thing, okay, if you read the question, okay, the question gives us that the length of the wire PB is equal to 100 centimeter with the resistance of PB is equal to 4 ohm. Okay, so this information is already given by the question. So we can use all the informations given. Okay, so now I want to calculate first what is I. Okay, so in order to calculate I, so as we know that current is come from 2.0 volt EMF. Okay, so we use accumulator here, right? And the accumulator is labeled as D, but here I label as EMF. Okay, doesn't matter as long as the value is correct value. Okay, so EMF is equal to IR, no internal resistance in the circuit. Okay, so I is equal to EMF over R. So look at in the upper circuit, how many resistance that we have. Okay, so in the upper circuit, we have RPB. Okay, so look at here, we have RPB, the resistance in the wire, RPB plus R prime. So we need to calculate the total resistance because we want to calculate what is the current flow in the upper circuit, right? So we must know what is the total resistance. So we must divide, okay, EMF divide R total. Okay, so ramai yang keliru. R sini nak ambil R mana? So it should be R total. If you look at in the upper circuit, RPB and R prime are in series. So make sure you total up all the resistance in the upper circuit. Okay, so let's write EMF is equal to 2 plus R total. Since RPB is 4 plus R prime. Okay, so we don't know what is R prime and I. Let's leave it as an equation. Okay, so now let's proceed to another one. So we want to solve for this one. What is the resistance of RPQ? So let's do the ratio method. Okay, so let's do the ratio. Okay, so since we know that LPB is 100 centimeter, okay, so LPB, so let's write here, LPB, look at here, at the bottom here, so we have LPB is 100 centimeter and RPB is 4 ohm. Then if the length is 60 centimeter, which is LPQ, then what is the resistance of RPQ? Okay, so we can write LPQ. So if LPQ is equal to 60 centimeter, then what is the resistance of RPQ? Okay, so let's do the ratio. Okay, so let's divide LPB over LPQ equal to RPB over RPQ. Okay, finally we can write RPQ is equal to LPQ over LPB times RPB. Okay, so we can use this information later in order to solve our problem. Okay, so as we know that VPQ is equal to IRPQ, so I want to highlight first. Okay, so now let's substitute so let's substitute VPQ first, where VPQ is 6 millivolt, and I is 2 over 4 plus R prime, and RPQ is LPQ, where LPQ is 60 centimeter over LPB, which is 100 centimeter times RPB, where RPB is equal to 4 ohm. So it's given in the question. Okay, so now we have all the values, so you can solve for R prime. Okay, so ini part matematik awak lah. Okay, so make sure you know how to solve this equation. Okay, so R prime mesti dapat R prime is equal to 796 ohm. Okay, so jangan careless. Jangan careless. Okay, so finish example number 4. Okay, example number 5. I think this example is very similar to example number 3 and example number 4. Okay, so this is also potentiometer. Okay, but this time E2 is come with the internal resistance. So given that E2, the internal resistance of E2 is 2 ohm. But don't be confused if the question give you the internal resistance of the EMF2, but still when the galvanometer at the balance point, okay, when IG is equal to 0, the potential difference of VPJ, okay, will equal to EMF2. Okay, VPJ will be equal to voltage across here. Okay, because EMF2 is also the voltage that across the internal. Sebab kita tak ada lagi apa-apa resistor dalam dekat bawah ni kan. We have the battery and the battery come with the internal resistance. So dia takkan effect apa-apa. Okay, so I think you can try this question by yourself. Okay, and the answer of this question, okay, the question asks you to find the internal resistance of cell EMF1 here, and the answer is 7 ohm. Okay, so the answer of the internal resistance of cell EMF1 is 7 ohm. Okay, so thank you guys for support my channel, and I hope you can do more exercises in order to understand each chapter in this semester. So please like and share and comments. Don't forget to subscribe. Bye. Assalamualaikum dan selamat sejahtera.